All right, happy Thursday. Actually, this is our last CONDG of the year. We'll talk more about that in a minute. But hello, YouTube. Hello, packed room of people. Welcome to CONDG, Central Ohio.NET Developer Group. Today, if you want to catch the recording later on or our past ones, you can check us out on YouTube. We probably should be pouncing on that new account once that comes out, right? Yeah. YouTube's doing their YouTube stuff, so we got to pay attention to that. But thank you all for subscribing. Those of you who did, we got over the 100 subscriber hump earlier this year. If you are connected with devices, make sure that you're not doing anything bandwidth intensive for poor Sarah, who wants to try to do any demos, and our stream that's going out to YouTube as well. Thank you to Improving Enterprises for hosting us, as well as many other user groups in the area. I was actually just ranting about Improving yesterday to folks in the community and just what they do for folks here, and how thankful we are for having a home and home with good Wi-Fi. Thank you to JetBrains for giving us our raffle sponsor. We'll be raffling off a license later on today for any JetBrains product. I think it's a 1-year license, so that should be a lot of fun. And then let's just plug a couple other groups in the area. We have the Central Ohio Azure group, which meets every second Monday of the month. That's a pretty decent group. I've spoken there before. I believe they are online still, but I might be wrong on that. The Global App Dev User Group used to be the Central Ohio App Dev Group and several other different names. They are an online group that speaks the third Monday of the month. Really good group run by Sam. Definitely recommend those folks. Columbus JS, I think this is maybe the first time I've had them on our slides, but they meet here as well. Guy Royce runs that, and they talk about everything JavaScript, usually a great time. And then CBus Data, formerly CBus Pass, which is a much more punny name, but they're still active, and they're talking about everything related to data and data management. So strongly recommend you check them out as well if you're very interested in data, which is probably likely given what you're talking about today. Yep. So this is our meeting calendar. There really shouldn't be too many surprises here because we're at the end of the year for us for regular content. So next month is Thanksgiving. And then the month after that, we're going to be kind of coordinating with the local groups for kind of a combined holiday party. So stay tuned for more news on that. We're looking over things for next year for scheduling speakers. So if you know of anybody, if you want to do a talk, if you have a talk that you do or have a friend who does, talk to us. We'd love to get them in here. We'd love to talk about new things and things that are interesting to you. So if you have a topic that's interesting, if you have somebody you know, if you want to try speaking, even sharing just about a side project, talk to Alan, myself, anyone else who's involved. We'll be happy to talk with you more about that, help you develop that. But also, kudos to the folks down in Cincinnati who run Momentum, who hooked us up with a bunch of folks to investigate for next year as well. So very cool. Raise your hand if you are hiring. Okay. Raise your hand if you are looking for work. Soon. Soon counts too. Soon counts too. Raise those hands. I know you all are looking for work. All right, talk to each other. Use the time after today to network. It's not too tacky to ask somebody for their email address or Twitter handle or whatever, and just stay in touch. Right. If you want to help us out, Alan, myself, Chandler, and Steven currently are running things. If you want to be more involved, helping on social or whatever else, come talk to us. We'd love to chat with you. And then tonight's presentation is my friend Sadukie, or Sarah, going to be talking to us about, what are you talking about, Sarah?
So I'm talking about its new name, which is Azure Cosmos DB for Apache Gremlin.
All right, well, I will let you kick yourself off there, and thank you for coming down all the way from Cleveland.
Oh, you're
really
welcome.
Appreciate it.
It's good to be here. All right, see what's going on? Hey, cool. And this is the first time that this talk has seen the line. So this used to be known as Gremlin API, but as of Ignite, so we're talking here mid-October, so really new stuff. But it's just a new name. It's not really new otherwise. We're going to talk about navigating data in Azure Cosmos DB for Apache Gremlin. Apache Gremlin, we'll talk about what that is. Now, let me, before I get into the slide and say all the cool stuff about it, let me tell you what I'm not talking about. This is a beginner-friendly talk, so I'm not going to go into graph theory. I'm not going into graphing algorithms. I'm not going into any of the deep dive stuff in terms of like fraud detection databases and recommendation engines and the complexities. Tonight's demo is going to be a very high-level recommendation engine. The reason why I'm doing super high-level is so I can show you the syntax for Gremlin. I am not going to be showing you any of the Gremlin libraries for like Python or .NET or Java. I'm not going into those libraries. We're going to go strictly just Gremlin. And I'll talk about why that is here in a little bit. So that's what we're going to be focusing on is Gremlin and graph databases, high-level, beginner-friendly. As you have questions, please jump in and say, hey, I have a question. I'd rather we catch those questions while we're still in context than we're switching topics and now you're like, you know that topic you had 5 slides ago? I'll be like, no. So ask the questions right away. And don't be afraid to ask questions because chances are if you have a question, somebody else in the room probably also has that question. It's just that they might be afraid to ask it. Don't be afraid to ask. No question is a stupid question. Ask as much as you can. If I don't know it, I will tell you I don't know and I will get back to you. And then I will post it in Meetup or I'll message Matt and Alan and go, okay, how do you get this information to those who attended? So I will make the slides available after. I will share the link to my gist, which is what I'm using to copy paste commands. That way you're not seeing me type all these commands off through the top of my head. All right, so this is what we're going to cover. So we're going to talk about graph databases. We're going to talk about the components. It's going to be a very short list of components to worry about. We'll talk about modeling. We'll talk about a decision that I made for the demo, why I made that decision. Again, keeping it easy, intro to Gremlin, and graph traversal. So what do you need to know about graph databases? Well, what are they used for? So you heard me mention that I'm not talking about fraud detection databases. We're not going to be building them because those get really complex. But you can use them for things like social networking. How many of you know somebody in this room who knows Matt? The reason I'm using Matt is because Matt was the one who said, hey, you should come down here and speak. And I'm like, sure. But how many of you knew me but prior to today? Only a handful of you, not all of you. But now you know me because you're here. You could have known me through Matt. Now think of like LinkedIn. And your first connections, second connections, third connections, graph databases, graph representation. That's what the social networks thing is. You can understand the area around you. You can use it to map out roles and who has access to what roles and what resources. You can go into who owns what things for data systems for your work. You could use these kind of things for doing IT networks. There's all sorts of uses for graph databases. How many of you have worked with your standard relational database SQL? Okay, just so I know where you're all coming from. Because I came from that route as well. I was like, SQL Server, I know my tables, I know how they interjoin, I know the outer join, I know the one-to-many, many-to-many kind of deals. Like, but at the same time, I couldn't like wrap my head around how I would go from that to this. They are not the same in terms, they're databases, and that's really about it. Relational data, think about it, you're looking at the relationships between the tables. Graph data, you're looking at the relationships between the entities. You're looking at the relationships between the things. Technical term. All right, so let's talk about some graph database components and the actual terms. So tonight you will hear me say either vertices or nodes. I should warn you, I do flip between vertices and vertexes. I am not consistent, but they both are acceptable. I had to double check that because I've had people where we've had the conversation of vertexes, vertices, doesn't matter. You're talking about the same thing. But there are nodes. Another term you'll hear is entities. And these are the things. And then they can have properties. So now we're seeing circles up here on the slide. These are things. These are vertices. These are things that are part of the demo. Look, there's even one for you. No, quite literally. This is you. And that's because I want you to understand this and be in the demo. CONDG, that's this group. So the way I created this data is I was on their YouTube channel. I had a link for that earlier. And I checked to see who was presenting on what and when. And so you'll see all those here in a graph form. Hi, Sam. You're in this presentation too. So C#, Azure, and CQRS just happen to be 3 topics that jumped out at me. I was like, okay, I'm gonna put them in here. These are all things that are related somehow, but we might not necessarily know how they're related. Well, CONDG covers topics. C#, Azure, and CQRS are topics. You are interested in Azure, otherwise why are you here? I'm talking about an Azure topic. And this talk, well, belongs in the Azure category. So now you start to see arrows. Those arrows, the order that they appear in doesn't matter, but the arrowheads matter. So you're going to see arrows pointing from a circle to another circle. They are directional for Azure Cosmos DB. I'm going to call it Azure Cosmos DB Gremlin API, but it's for Apache Gremlin. The new name is still settling in. If you're familiar with Azure Cosmos DB at all with their other APIs, they all got renamed to Azure Cosmos DB for something. And they have a new friend too for PostgreSQL. You can ask me about that too. All right. So we have the vertices, then we have the edges. That's what these arrows are. Then what we have is the graph. The graph is the collection of the edges and the vertices. These are the 3 main concepts you have to worry about when working with graph data. You have to worry about the things, the relationship with the things, and the overall container of it all, which is the graph. So those are the only components we'll be talking about. But first things first with these edges. The edges are the relationships. That's where you're starting to see these arrows. So with the edges, they are going into a vertex. So think about it when we're looking at where is that arrow pointing. It is going into a thing. In and out are keywords. There's also both. I will not show both just because it's one I always tend to forget about, but I will acknowledge it exists. So when you need to deal with all edges for a thing, for a vertex, you'll use both. But because I want to show traversal, I'm going to show navigating, hence the title Navigating Data. We won't see both as much as we'll see in and out. Now when I'm going with edges, you've got to think about this from the edge. That topic is what's known as an in vertex. It's called an in vertex because the arrows are coming into it. Now from the edges, looking at it from the topic standpoint, those arrows are coming into me. So if I'm that topic, those arrows are pointing at me. So I am in vertex, and those are my in edges. Same thing with out. So out, the arrows are coming out of me. The edges come out of a vertex. So we have here our friends C#, Azure, and CQRS. There are more, I promise you, but they're not on the slides. We'll look at the data. But these arrows are coming out of those vertices or out of those nodes. And so from the edge, these C#, Azure, and CQRS, those are considered out vertexes or out vertices. And then these edges in relation to the nodes, those are considered out edges. Now, in and out will take a while to get used to. So when you're looking at that and you're like, okay, I think I got it, and then maybe a couple minutes later you're like, no, I don't got it, don't worry about that. We will walk through the presentation. I will be stepping you through along the way. I will not go, we're going to go out and in and out and in and leave you hanging. I promise you, I will walk you through and navigate it because that takes a while to do. There are times too when I'm working with this data where if I can't visually see it, because this is all stored in JSON in Azure Cosmos DB, if for some reason I'm just working with JSON, I'll draw out my relationships on paper just so I can see it. I'm a very visual person with the relationships. So if you were to tell me something like in and out, I'd be like, hold up, let me draw it out. All right, so for this particular example, Azure, C#, and CQRS are considered topics. So I've labeled their relationships or their edges as ISA. ISA is considered a label. Azure, C#, and CQRS, those are considered names. We'll talk about names and labels here in a little bit. But ISA for the edges is a label. And then looking at these with relationships, so again, now you've got topic. You have the relationship of is coming in. For C#, Azure, and C4S, those arrows coming out, those are out edges. If it seems like I'm harping on ins and outs a lot, it's just so that you get a feel for how that falls through. All right, so with ins and outs with edges, so now we're looking at you, all of you, are interested in Azure, or at least for tonight, you're interested in Azure. And in the Azure category, it happens to contain this talk. There are a lot of Azure talks that have come through CONDG, so you will see more in a later slide. But this is, so what you're looking at here, we can walk this graph or traverse this graph. You're going to start with you. I want to say that I am interested in Azure, so I have this edge. This is an out edge for you, which Azure Cosmos DB, the way it stores its data, it has the vertices and the edges. The edges are stored with the vertexes that they're coming out of. So in this case, this edge is stored with you. So I'm going to say I am interested in Azure, so I'm going out of here. I'm going to take my edge, I'm going to go into Azure. And how am I linked to this talk? Well, so far that's one step of traversing this. Now I'm going to say Azure contains this talk, so I can walk through that way. So I go out, come in, go out, come in. Like I said, I won't leave you hanging. Yeah?
So are these vertices, are they out vertices and in vertices at the same time?
They can be. They can be.
Topics?
So let's talk about Azure, because Azure is just that. So Azure is considered an in vertices or in vertex because of this one coming into it.
Right.
But it's also considered an out for this relationship.
Okay.
So a vertex can be both an in and an out. It's a matter of the perspective.
Right.
So that's something that you'll hear me talk about when we're looking at the drawings, is we'll talk about which perspective are you looking at it? Are you looking at it from the term of the vertex, or are you talking about it from the term of the edge?
Okay.
So yes, you can have both. And in that case, just so you're aware when it comes to storing it, this interested in relationship will be stored with the U node. This contains relationship is stored with the Azure node. Again, because these are coming out of. Now for easy demo's sake, most of my nodes, I think with the exception of Matt, he's like, I'm always the exception. No, in this case, you had multiple videos on YouTube, so that's why you're the exception. But most of my nodes are going to just show one relationship coming out, and it's just because that's the way it was designed. The exception is Matt because he has 2 videos on YouTube, and so you'll be able to see that. Look, he's shaking his head like, why? I mean, happens. This talk, when I do this talk, by the way, I do it themed to whoever I'm presenting, as long as Azure's cooperating with me. Last time I did this talk, it didn't want to cooperate, and it was for the Azure Cosmos DB team. So it happens.
That's great.
So I used my Data Weekender talk instead, which this is very much, the layout is based similar to it. All right, so let's talk about ins and outs all together, because I'm going to be getting away from ins and outs here shortly until we get back to the Gremlin stuff. All right, so ins and outs. This is Azure Vertex. This is the one in the middle. Interested in, because the arrow is pointing to it, this is the in edge. Contains arrows coming out of it, that's the out edge. For the interested in edge, so from this perspective, U is where it's coming out of, so at the out vertex. Again, we're looking at this interested in relationship, U, out vertex. Azure is the in vertex. So you see what I was saying when I'm talking about the different perspectives? And framing it, okay, who are we looking at? And then who's coming in, who's coming out? And then for the contains edge, Azure is going to be the out vertex, and this talk is going to be the in vertex. Now, we'll see what that looks like in Gremlin syntax here in a little bit. All right, so let's talk about graph database modeling. All right, so when you're working with a graph database and how you do the modeling, if you have this in a relational database, I'm going to frame things with relational database because when I asked you all who had access or experience with relational databases, I think just about everybody had their hands up. With relational databases, you have those tables, you have details about the things, the nodes. When you're looking to explore relationships, you're not necessarily going to bring in everything that's on that table. You're only going to bring in the relevant things for the relationship exploration. Now, for demo's sake, I have on my talk node, I have a couple properties so you can see dates and so you can see numeric values. But I didn't necessarily need to bring those in. I'm just bringing them in for demo value. When you're analyzing data for their relationships and understanding how things come together, only bring in the data that you need for that analysis. So just because it's in a relational database somewhere doesn't necessarily mean that it also has to go into the graph representation. It's something that I have to point out is key because people are like, oh, I just bring in everything from my relational database for that node. No, no, no. Unless it's really relevant. But try to not bring everything in. Now, when you're doing data modeling, you also need to know how these things are stored. So as I mentioned, the out edges are stored with their respective vertices. So interested in it is stored with you. The ISAs are stored with their respective topic nodes. Topic doesn't have any edges stored with it because it only has in edges. It has no out edges. Now, when you're deciding how you want to store your things in the graph database, you need to identify, again, the relevant properties, not everything. You need to think about read and write usage. For everything I've seen, and I've worked with and talked with other people, you're going to see initially a write, but you rarely are going to update it unless you're reading off of live feeds. You're typically looking at stuff and you're looking at the relationships as just an analysis process. Now, when you're determining your read and write, that will help you to figure out how do you want to structure your nodes. Next slide will explain that a little bit more. So with Azure Cosmos DB for Apache Gremlin, ooh, that background, it is meant for scaling. And so it has this concept called a partition key. The partition key is used with vertexes. Again, the edges being stored with their source vertexes. The partition key, when it's used for scaling, it's scaled horizontally. And so that means that you can have things in chunks. I don't demonstrate this in our demo tonight. And the reason why I don't demonstrate it tonight is because that's a conversation in and of itself that could get really deep really quick. So I didn't want to go there. So you're going to see that my partition key is labeled PK for primary key or partition key. And I set it to PK for everything. If I use the partition key for a field, every one of my nodes has to have that partition key field on it. And that partition key is used for balancing it across the distribution. So let's say there's an example I used with the holidays last year, where I talk about holidays, and I talk about like when they happened, and then I categorize them on their different like holidays. Why are they happening? Are they religious? Are they based on some other thing, federal holidays, things like that? So those categories, they balanced out fairly evenly, and so I was like, okay, I'll use that for my partition key. But the data I'm working with today, there's no particular field that stood out as, hey, this would be a good partition key, and I can't use the ID or label fields. Those are restricted. That's what this thing with the really funky background is showing right now. Is that the ID and the label, you can't use those as partition keys. Those are already handled on the server side. So when you choose your partition keys, if you're working with read-heavy queries, think about your where clauses. Think about how you need to, like, are you working with particular groups? If you're doing write-heavy queries for some reason, then think of your high cardinality fields. Those are keys for your partition keys. And then when you're in a scaling situation, when you're querying for single nodes, include that partition key so that the cost of the query is lower. It knows exactly where to go to find it. So, more guidance on that. There's a link for that. You will get access to the slides after this. Again, all of these links are going to be in there. All right, so we talked about graphs. We talked about ins and outs, vertices, edges. Next, let's talk about the product. Let's talk about Azure Cosmos DB for Apache Gremlin. Azure Cosmos DB for Apache Gremlin. I don't have the standard Azure Cosmos DB slides in here because Gremlin is a little bit different. It's the Graph API. This Gremlin, he's part of the Apache Tinker project. So I can't take any credit for, I can't draw my way out of a box. I'm horrible at that. But I can tell you where this guy comes from. Azure Cosmos DB itself is a multi-model database. So there's the Gremlin API. There's one for MongoDB and document databases. There's one for Cassandra, which is a column store. There is one for their standard, they call it now the NoSQL API. It used to be the Core SQL API. And then Postgres is the new one that they announced at Ignite. And that is taking relational data at scale. So I can't say that it is a NoSQL database anymore because now we have relational involved. But it is a multi-model database. But for Apache Gremlin, this is where we're getting into the implementation using the Apache syntax. Go ahead.
I've not heard of NoSQL before. What is that?
So NoSQL, it's, some people think it's like not SQL or not only SQL is the other one that you'll hear for it. If you're familiar with SQL, select star from, things like that, that syntax for your relational database isn't always going to be the language that you're going to use to query things. MongoDB has their own query language, so querying documents, think of it, you're querying JSON objects. How do you query that? It has its own syntax. Cassandra uses something called CQL, which looks like your standard SQL, but it has its own set of gotchas. The Core SQL API or the NoSQL API allows you to work with JSON objects in Azure Cosmos DB. Again, it has its own gotchas. They're different from T-SQL. There's all sorts of things where you're like, oh, this looks like T-SQL. Why didn't this work? Oh, because I'm not in the SQL environment. I'm in a NoSQL environment. They have their own set of stories. Gremlin doesn't look like SQL at all. So rest assured, you're going to look at this and be like, where's my select statements? Where's my where clauses? They're not there. Gremlin is a different Gremlin, dare I say? I told you, dad jokes are common. I'm a mom. I'm married to a dad with dad jokes. I have friends in industry, dad jokes. It's awesome. What I want to show you tonight, we're going to query in the browser with Azure Data Explorer. We can add to a graph. I will not show you adding to the graph because I couldn't reset my database because I forgot I didn't have a Git repo. You all know what happens when you have code on your machine and you don't check it into a Git repo. You won't be able to get it. So I will talk about those syntax for that. I think she's killing it with these bad jokes. Can't help it. And then I'll talk about building graphs with the API libraries. I think that's in a couple slides here. Now, Azure Data Explorer. So what is Azure Data Explorer? Carrie, not the one that we were talking about in trading. This one is the one tied to Azure Cosmos DB. So Azure Cosmos DB, you'll create an Azure Cosmos DB account and tell it you want to deal with the one for Apache Gremlin. And then there's an option in there for Data Explorer. You know what? We're going to talk about it. Let's go and look at it. Let me see if it's going to let me move it over. Well, full screen. There we go. And can I zoom it out? Alright, so we are in, this is my Azure Cosmos DB account. You can tell that right here. Azure Gremlin API. So their screen is still going to show Gremlin API. Let me show you how I got into this first. So Data Explorer, I'm going to open up my window here. This is the menu that appears on the left, but because I'm on a small screen, it's not there. Data Explorer appears. It's normally here. There it is. Like it's toward the top, there's Data Explorer. It's going to appear on the left-hand side. So I'm already in Data Explorer, that's why it's highlighted. But just so you know how I got into here, is I had created an account. Now I have this Gremlin API. Now I have what's known as a database that is right now called Community. I have this collection called Speakers. So database and collection are some Cosmos terms that you'll see. And then within my speakers collection, I have this thing called a graph. So I'm going to click on the graph. Now when I click on the graph, it takes me to this graph tab. So now I can run Gremlin queries. This g.v you're seeing, that's a Gremlin query. G, remember when I was talking about terminology, the three main things to know are going to be your vertices, your edges, and your graph. Think of G as G for graph, V for vertex, parentheses. Think of it as your collection of vertices. And then edges. Anyone want to guess what edges is?
E.
It is E. So we got G.V and G.E. I want to go ahead and run this. This is the default hello world of Gremlin land. I'm going to close this side up. We're not going to talk about anything else that's there. All right, so when I do G.V, it gets me all the vertices. I'm going to collapse that. Let's see if it's going to let me drag it. Drag it. Whoa. So you can see there's nodes. Hold on. There's the full. Which is still not really, it's harder on the smaller screen. And it's very fiddly with how it allows you to resize. Even on my big 38-inch monitor at home, trying to get it to scroll and to pan, it gets weird. But just so you can see what we're looking at. Now, I've already come in here and went under style. I want to show you what happens. So you'll see under style that it shows a vertex node as an ID, and there's none. Now, I was kind enough to assign names to the IDs so that we have an idea of what we're looking at. Normally when I do this demo, I don't assign the IDs and I let GUIDs go crazy, which is really, really gross. But you have no idea what you or Azure are. And like these 3 dots, I can click on the 3 dots, see what else is connected to Azure. Oh, there we go. There's some GUIDs.
It's pretty intuitive.
You all know what this means, right? I mean, Azure is all about 1089, that GUID. Who deals with GUIDs and knows what they are? Now, hold up. To be fair, some of us are old enough to know that we've been working with Windows long enough that we know GUIDs for special folders because we've done it so many times. So I shouldn't make fun of those of us who know these GUIDs, but just be warned, you're not expected to know what those mean. We'll come back under style. I want to actually see the name. And I want to have my nodes colored by their label. We'll look at code here in a little bit so you can see what that means. And sources, targets, all neighbors. I'm just going to leave it to targets right now, and we'll see why that is here in a bit. So now, notice U has a color, Azure has a color. If I expand out Azure, we are no longer GUIDs. We now see that there's these talks, like one config to rule them all. That's Sam's talk from last month. That navigating data, that's this one. Automating my dog? I mean, really, who automates their dog? Matt. Matt. Now what's nice is I can select this here, and then I can come over to properties. I'm going to get out of the full screen, and I can go down to the properties. So you can see, automating my dog with Azure Cognitive Services is the full title of the node. The ID, some of my IDs didn't come through, that's fine. It decided to do good. But now I have these other things. So I mentioned with vertices that they could have properties. These are properties. So I have a vertex. This label, this is like that categorization of what is your thing, what is your entity. I have talks, and we'll look at the slides as to what the other things are. But I have talks, I have topics, I have persons, I think there's one more. The talk actually has a name. The type field that I forgot to take out. So that's there. That's going to be irrelevant to tonight's presentation. But then I have the time. So when did it appear in YouTube? And this is from an Excel sheet, so it was just August 2022. So that's what it did. Month and year, these are integer values. This is a date time. And then PK, that's because I didn't want to deal with the partition key. I wanted it all to be just one huge graph. Some graph platforms do support horizontal partitioning in the partition key. Some are just a graph without the partitioning. So this is essentially a graph without the partitioning because it's all in one partition. Just be aware that the Cosmos DB approach to things is having a partition key and doing horizontal scaling. So these properties are what I have here. I could come over on the left-hand side, so there's results, graph, and then this is the properties pane when you're working with Azure Data Explorer. So I could come in here and I could be like, okay, who else do we have in here? Here's Alan Barber. You weren't getting out of this that easily either. But I can see then with Alan Barber, I can look at the graph, and you can see he did a talk, and that's, I think, the CQRS with Mediator, if I remember right. And so I could say, okay, if I select Alan Barber, and then go to the properties, you can see he's a person, and there's his name. So the person entity, I didn't bring anything else in there other than their name, and then their ID, which happens to be their Twitter handle. Jeffrey.
Does it support multiple labels for a given vertex? Like, can a person be a person and a manager, or a person and an employee?
I have not tried that, so I can't tell you yes or no on that. That's something I'd want to try to see.
Okay.
I don't think it does. That would be awesome if it could, though, because I could see a use case for it, but I don't think it does. Now, I did say, go back to here. Or not that one. Where my results go? Okay. I collapse that. I am full for that. There we go. Okay. The reason why I knew I was in full is because I was looking at this and I could see the properties, but I couldn't see my results. And so I was like, what happened? I'm in full. I do this. Now I can scroll back down. Something else to note, the results are JSON. Let's see if it'll let me scroll so I can show you. The results are JSON, and I have on the slide some of the JSON excerpts so you can see that a little bit better. All of the nodes and edges under the covers in Cosmos DB are stored as JSON. Now, I'm not going to demo it on here because I don't have all the tools installed, but you can query it using the core SQL or the NoSQL API to see what the JSON looks like. So I've used my friend Hassan Savran, Savran Web on Twitter, has a Visual Studio Code extension, so you can query using that SQL API. So I did that over the graph database one day just to see. Just because you can do it does not mean you should do it. So do not query over the SQL API to see what the graph data looks like. That's gross. Use the Gremlin API in the Gremlin syntax. That's a lot more appropriate than trying to finagle your way through JSON. Don't do that. Just so you can see that's how it's stored under the covers. Okay. Up here, this G.V, this is where I'm going to be running various queries. So we'll show that. What else do I want to show you? I guess if I go back to the results, if I go back to the graph, bring the results, and if I can find the Azure one, the reason I want to show Azure is because it has all sorts of things going on with it. So it's got the ins, it's got the outs, it's got the person, so it's got like you. If I select Azure on the properties, you'll see what they have as sources and targets. So sources and targets are your edges. You'll notice in the graph representation in Azure Data Explorer, we have the labels for the vertexes. Or not the labels, right now we're showing the names. They're colored by label. But we can't show the labels for the edges. That's just with whatever tool that they're using to render this does not show it. But you can have the labels showed on the property. Yeah?
So in this terminology, source would be your out vertex, and then target would be your in vertex?
So
is that a Cosmos DB-ism, whereas in and out is a Gremlin-ism?
Yeah.
Okay.
Yeah, so source and targets are what you're seeing here. I've seen that only on the Cosmos DB. I haven't really seen it elsewhere.
Okay.
But Gremlin, the G.V, G.E, that you're going to see for the other databases that also have Gremlin API. That's the standard syntax. The other thing I'm going to make note, and I know I have a link to it in the slides, is that Azure Cosmos DB shows some of the Gremlin syntax, but it doesn't have 100% compatibility with it. So there are gotchas as to what works and what doesn't work. They have a document in the docs for that. All right. So the edge labels and the targets, you can see they can have different things as well. All right, let's go back to the slides just to move along. So we showed Data Explorer. With the internet working, it makes it easier for me to actually walk you through it. The only other thing I'll point out is that with the Azure node, there's a kind of, so we have different labels going on here. This is a group. This is a person. Azure is a topic, and then these are talks. So they are all different types of entities, or different types of vertexes. We talked about the different sections. I usually try to get screenshots in case the internet doesn't work, so but I'd rather show the demos if I can. All right, so let's talk about Gremlin. Notice all sorts of Gremlin folks up there. Yes, even PHP, because I have to make sure it is not out to it. Some people are like, oh God, PHP. Sorry, that's my happy spot. So this Gremlin comes from a project called Apache Tinkerpot, and it is a procedural language. It is what's known as a pipeline execution, so you're going to read it from left to right. You're going to do this thing, the results of that thing is going into the next, is going into the next, is going into the next. So that's why when we say pipeline execution, run this thing, pass that result into the next, which goes to the next with some parameters added in between. We'll walk through that. There are various variants of Gremlin, Java, Groovy, Python, Scala, .NET, and more. Check out the variants. I will be doing Gremlin.net next month for .NET Conf, so stay tuned if you want to learn more about how to do that with C#. But for tonight, we're just going to stick with Gremlin. I'm not going to keep mixing languages because that gets confusing quick. All right, so we're going to talk about vertices in terms of Gremlin and the Gremlin syntax. I've got it looking right now at you in Azure. Remember, you're still interested in Azure, right? At least, hopefully for this talk, I've got you interested. But I'm looking at the U vertex. And so I've got this screenshot here. You can see the different properties. You can see the targets. When you start your command, all of your commands in Gremlin start with G. G is that graph. That's your graph traversal. Traversal means you're navigating, you're walking the graph. G.V, give me all the vertices. V has parentheses. If I wanted to start with edges, that's coming up on the next slide. That's G.E. With G.V, give me all the vertices. Now let's say I want one with a specific type of label. In this case, maybe I want all topics. It would be GW.hasLabel topic. You could do it topic, you could do talk. If you don't know what the labels are, that's coming up in another slide. So rest assured you'll be able to see which ones are available and unique ones at that. Now, say you want to find one with a particular property and value. Say I want to find a talk that happened on January 1st of 2021. I can say .hasLabel talk. The reason why I'm saying .hasLabel talk is because I want to narrow down which set of vertices I'm working with. Give me only the talks. Person doesn't have time associated with it. Topic doesn't have time associated with it, just the talk. So let's just narrow it down. So I start with all of them. Give me the vertices. Give me just ones that have the label talk. And find me the one that has the time with that timestamp in it. Now, why does that timestamp have the full year, month, hours, and time? Because that's what happened when I exported the data. If I were to take it off and just put the date, I wouldn't get the node back. I have to have the full timestamp out.
Is it a string match?
I'm pretty sure it's a string match.
Yuck.
No. Yeah?
Yuck.
Yuck. Yeah. These are gross. They're still gross in Gremlin. But you can get vertices with a property value based on the has. So let's go back into here. And I'm going back to my Gremlin database. And I'm going to get out of my full screen mode. So let's close down properties. Oh, nested scroll bars. Close down the properties. Close down the full screen. Take me back. All right, so we're at G.V. And say I only want to see the topics. So I do hasLabel topic. Yes, I know I was going to copy paste some of these, but we'll do that for the more complex queries. And execute. So now, if you look over here, you can see all of my topics, like Azure, C#, machine learning's in there, GraphQL, some security, and other topics as well. So this is to give you an idea of what hasLabel look like. So hasLabel is here. Now, if I wanted to say, find me topic that has the name Azure, that. So has, the property names in quotes, the values in quotes. If you have quotes within the value, you're going to need to escape them. So like slash and apostrophe if there's an apostrophe in there. But you'll see there's my Azure node that comes back. And because of the graph representation in Azure Data Explorer, it has the graph of the node. So you could expand that and you could see how is it all connected. That's G.V. Graph response, again, screenshots just in case we couldn't do the live demo. The graph properties, this is what you're going to see when you're looking at the queries from a vertex perspective. You'll have the vertex, you'll have any of the edges will appear in sources or targets, depending on their relationships. Now with edges, so now we're talking about starting with G again. G.E to give me all the edges, and then maybe I want only the edges that have contains. So it would be G.E, so give me the whole graph, I only want the edges, I only want the ones that are labeled contains. That's that whole pipeline execution. What are you going to see? Sources and targets, those are edges. So if we wanted to navigate to those, now, this representation that I'm showing you here with this Azure Vertex is only available with the vertices. When you're querying the edges, you won't have a cool representation of a graph and all prettiness. No, you just get JSON. So you're going to get a result like this. Now, I have JSON representation so you can see that we have an edge. How do I know this is an edge? That type. Here, type vertex. So you can see what the JSON representation is for a vertex and for an edge. Told you they're stored in JSON. I'm going to show no tricks up my sleeve. This is what we're working with. The JSON response is what you're going to get when you're working with the API using languages. But different tooling will handle like mapping those to objects differently. Gremlin.net, for example, there is a Fluent API. It cannot be used with Azure Cosmos DB right now because Azure Cosmos DB for Apache Gremlin does not support bytecode. It's listed on the roadmap, so we'll see it eventually. But the tooling allows us to do this kind of query without having to pass strings once they get there. For now, we're passing strings in. All right, now edges as sources. So we're looking here, if they're a source, notice that these have relationships coming out of them and going somewhere. Those are sources. That's where they appear here. Your targets are all the other ones. That's how I was like, I'm not going to draw a funky rectangle Tetris piece. Nope, I'll just grade it out. So all of these, they have edges that are coming into them. So those are why they're called targets. All right, so graph traversal, I've been talking about this and walking through it. So again, it's written from left to right. See it as a pipeline. We start with G, then we choose either vertices or edges, depending on what you're looking for and what you know about your graph. You can go in, you can go out, or you can do both. So I do acknowledge that both is a thing, but all the demos I'm going to show are ins and outs. Now, where do you run these queries? So you can run these queries in Azure Data Explorer, or you can do them in Azure Cosmos DB for Apache Gremlin calls. Don't panic about it typing. I do this presentation online, and sometimes I can't count on Azure to actually run properly. Servers are, they happen. And so this is what I was showing on how to actually go in and change the name into label. So all the demos I'm doing tonight, Azure Data Explorer. All right, from the vertex perspective, again, talking about perspectives earlier, now let's actually see what it looks like in Gremlin. So we're looking at Azure. Why am I using Azure? It's because it has both ins and outs. That's why I keep coming back to Azure. You don't want to pay close attention to the arrow direction. So we're going to start at Azure. And if we do a g.v.hasName Azure, that's here. And then I want all the in edges. That means everything pointing at it. You'll see that it has two edges. So in E, anything pointing at it. Out E, anything pointing away from it. And so that's when we have 5 edges. Now, When we look at it, it'll have the out E because everything's headed out of it. How do I know that there's 2 and 5? Yes, I can look at it and say, that's easy, but I can also run the queries to help me with that. So let me open up over here, my mouse, clear mouse. So I want to show you in E, yep, has name. Has what? That is not. What is it doing?
Single quote, double quote.
Yeah, that is not at all. It's got some funky line.
Smart quotes.
No, it's.
The demo gods are not amused.
But yeah, they were not amused, and that's okay. I had this happen to me earlier today, and I was just like, you're not going to do this to me, and if you do it, well, then I will just press F5 to refresh. I will come back into the graph. I will come back under settings. That's fine. Okay, so if I come into here, Control A, Control V. Wow, that is not at all what I copied and pasted.
Is there an extra character at the edge there?
No, I have no idea what this thing is. They changed something on me? Oh, I can't even. Oh, there we go. Okay. Execute Gremlin. There we go. Like, so that tells me my INI, and there's my JSON out. But if I had a lot and I didn't want to count it, I could just do .count.
That squigglies were bad. That something was wrong there.
Yeah.
Squigglies.
You know.
I think it's a browser spell check.
That is a browser spell check.
Okay.
And the browser's like, you're not spelling any of this right. Sorry, browser.
It's not English. It's
You learn to ignore the squiggles. I'm going to tell it execute my query, and then my JSON comes back, and I have 1. What?
Well, do you have name of Azure?
Yeah, has name Azure.
Yeah.
And 5. I don't know why. You know what? It probably failed on a load, and that's probably why it only has 1. Let's go back to the INE just to see the results. And execute. And come under the JSON. What?
That's
All right, I'm going back to slides. You know what? This is why I get screenshots. This is why I have screenshots. It was doing that to me earlier, where it showed all the autocompletes of the things I've done before, and it wasn't showing the right room on it. I'm like, okay, listen, I understand web development's hard. I get it. That's where my core is, but yeah.
Can you go back to the last slide?
Yeah.
Why does it say returns edges if it's GB? Doesn't V return vertices?
So the reason, the question for all of you in the back too, is for those at YouTube. So the question was, why is it returning edges if it says G.V? And it's because of the traversal. What it's going to return actually has nothing to do with that. It has to do with what is the last thing in the Gremlin statement. So because I stopped it in E and out E, it's going to return edges.
Gotcha. Okay.
So the G.V and G.E, that's just your starting point. Do you want to start with vertices? Do you want to start with edges? That's going to be your preference. Probably going to depend on what question you're trying to answer and how well you know your data. But that last endpoint is what it's going to look for. And what I'm dealing with here in Azure Data Explorer, I don't need to put terminators. Some of the Gremlin stuff has a terminator requirement. I have a link at the end with a book that talks more into Gremlin syntax and iterators and things like that. All right, so edge perspective. So GW has named Azure in E. We'll get you all of the ones that are in edges. This is going to be the output. There should be 2, but for some reason, it only is picking up the 1. All right, now some other syntax to see. So If you want to know the labels, you're like, I've got this graph database, somebody else loaded it, I have no idea what I got myself into. Label. Label is key. You can run it off vertices, you can run it off edges. Doesn't matter. .dedupe. Now, if any of you have been playing with pandas, you're going to see some pandas things that are fairly similar. So you might feel more at home with that. But dedupe, deduplicate. I only want the uniques. So give me the unique labels, give me the unique labels for both the vertices and the edges. Yeah.
Like a SQL distinct.
Like a SQL distinct, exactly. But the thing is, if you leave off that dedupe, the GW.label is going to get you the label for each and every vertex. That's why we do a dedupe. Because I only want to see the uniques. I don't need to see all of the edges and all the vertices and all of their labels. Why would I want to do that? That's just a little too much. When I'm exploring my graph database, like let's say that, I know Jeffrey, he deals with graph databases as well. He speaks about Neo4j, and we've talked about graphs in general. So let's say he created a cool graph database and said, Sarah, you gotta check this out. I already preloaded it for you in Gremlin API. I know you like this. Like, okay, what did you give me? I'm gonna start with this GW.label dedupe and G.E.label dedupe. I want to see what kind of objects am I working with, what kind of things or entities, what kind of vertices, and then what kind of relationships or what kind of edges. Unique values for labels, so you get into .values. Now, again, we're looking at the pipeline. Give me the graph, so give me everything. I only want the vertices, because that's what I want to query. I only want the ones that have topics, and I want to know what kind of topics are available. That's where we get to the values. You'll see things like C#, Azure, CQRS, and so on. The unique values for a property. So for a label, we did the has label. For a property, that's not, so I did the G.V has label talk, just to filter it because we only want to look at the talks, because talks has a lot more properties to query. That values, you can then specify that property name. And so that's why I say that values and then put year in there. So I want the unique values for property. How do I know I want unique? Because that's what the dedupe does. So take the graph. I only want the vertices. I only want the ones that are labeled as talk. I only want to look at their value for year. And I only want unique values of years. See how that all walks out? And the unique values are 2020, 2021, and 2022. Because that's how far back YouTube goes for this group. And in case I haven't said it, check out their YouTube channel. All right. So adding edges and vertices. This one I'm not going to do a live demo on because I've already run it, and I didn't have my script to reset my database. But G.addV is adding a vertex. Adding a vertex, you need to include the label. So what kind of thing is it? In this case, I'm going to add a topic. Then you're going to set any properties. All of my things, I assign names so that I know what I'm working with. So the property, put in name. I'm going to say Azure Cosmos DB is a topic. And then I did .property PK because it's my partition key. You have to, if you have to set a partition key on creation, when you add a vertex, you have to include that partition key as part of the addv. If you don't, you won't be able to add it and it will throw an error. It's very good at throwing errors. Reading those errors, there's a lot to sort through, but it can be useful. Adding an edge. So adding an edge, remember those edges are stored with where they're coming out of. However, you might think of it when you draw it like to's and froms. Draw it out, think of the relationship, and then build the query. So in my case, Azure Cosmos DB contains this talk. So I want to start with Azure Cosmos DB. This is my new node. And I'm going to add an edge. And I'm going to say that this topic, Azure Cosmos DB, contains this talk. So it's going to go from here, and it's going to. So I'm using the to keyword to say, where's my edge going to? And then, so add E, add an edge. This is the label for the edge, that's the contains. To, so where am I drawing that relationship to? This parenthesis ends over here. And that G.V all the way to here is getting the vertex for this talk. So that's what's going on here is I'm going to attach Azure Cosmos DB to this talk. And then what's going to happen is it's going to look like this. So this talk is now connected to Azure. It's also connected to Azure Cosmos DB. And it's also connected to me because I'm the one delivering the talk. Again, you can see that here in the sources. There's Azure Cosmos DB. So prior to it, did not have that, but when I ran this command, where the add v, and then this one here, that's what added that relationship in. Yes?
Is that creating the second vertex, or is that only creating the edge between two vertexes?
The query, hold on, let me grab my laser pointer and make it a little bit easier. Where's my mouse? There's my mouse. Okay. So this query, yeah. Where did that mouse go? All right, so this query up here, this g.v add topic property name, that's creating the vertex. That's creating the node itself. And then this long thing here, this is actually one line. I break it up so we can see the chunks a little easier. This is what's creating the relationship. So you have to create the vertex first before you can create the edge. Kind of like the dependencies for SQL and making sure that you create the data first before you put the relationship there. Or create the relationship there before you can enforce it, things like that. Yes, go ahead.
Is there any concept of like identifiers that you could say, give me node A, and give it an identifier, and then node B, and then kind of structure your queries such that it builds up incrementally, or do you have to always express the entire thing as what that was?
So you could say, give me g.v has ID.
Like var A equals g.v has name.
Oh yeah, so you can assign them like to variables. You can. I don't have a demo for that because it gets a little too far in the weeds.
Okay.
But you can do, there's if you go further in the documentation, look up as. As will allow you to store, so you could say, store this as A, store something else as B, and then reference those later on in the chain. Yeah, that gets a little more in-depth than I want to for an hour presentation, so. All right, so that's our new vertex and new edge. You can do aggregation. I showed you count. This is what happens. There's 21 talks in my data set. I did a gw.heads label. I only want the talks and call a count on it. But then when I start to think, I'm like, all right, we've got 3 years of videos on YouTube. How many sessions were done for each year? So this is where I got into the group and the by and the other by. Now, let's talk about that. So g.b, give me all the vertices, has label talk, so give me only the talks. Dot group is saying, okay, we want to group them somehow. Think of it like you group by in SQL. What happens when you want to group by multiple fields? That's what this particular, well, this one here is only going to show by year. The next query will show multiple fields. But we're going to do group, and then I'm going to group it by year. Then I want to be able to see the count for each year. So that by values name is going to count the names for that group. And then, so 2020 has 8 talks, 2021 has 8 talks, 2022 only has 5 talks. There were some private ones on YouTube video list, and so I didn't include those in there. But this is how you deal with that, is you have the group and a by, and then that second by is to get those counts. Yes?
If you're grouping by year, do you need the names of the talks?
I don't need the names of the talks in terms of a group, but I do need to be counting on a field. So the reason why name is there is that's what I'm counting on. That's the aggregation part.
So if you do count after the year, you get 3.
Yeah. That's how I include the aggregation. Now, we do some more aggregation with the order by and the filtering and ordering on the next slide, so you can see these a little more. I'm going to caution you, order, and then by, and then if you have another field, you do another by. Don't do order and then by, and then order and then by, because that resets the ordering altogether. I've done that. So trust me when I say, if I were to say, I want all the talks ordered by year and then month, then I did this g.v has label talk, order, parenthesis, dot by year. If I injected another order and then by month, it would only be ordered by month. Year would have nothing to do with it. So if you have multiple orders in there, that order is going to, the order keyword will reset the order to that point. So if I have order and then by year and then another by month, it really is going to order it as you would think, by year and then by month. That order keyword, I tell you, I'm just like, why have I run into this issue? Because there is limit, which I have above that. So the limit, think of it as like your select top in SQL. So I want to select top 5. I'm going to just do a limit 5. Getting the talks names and values ordered by the name. So when I need to order by a particular value, I'm going to use values and then specify the name of the property whose values I want to order by. And then the by is telling you which property that value's name is giving me only those names. I don't want the full vertex object. I just want the values. Sometimes it's like when you go to those websites for recipes and you're like, I just want the recipe. I don't need the story. Jump to recipe. Just jump to the values. All right, filtering and ordering. So you can mix them. You can have your has labels and hases. You can stack your hases. This query here where I do has label and then has, I could very well just do has and not have the has label. Some flavors of Gremlin, I say flavors because some deal with the implementation where you can put the label in the V. So you can say g.v in parentheses, say talk. Cosmos DB prefers the has label, doesn't seem to support the other way. But I could say, okay, year. Now, the reason why I chose this particular query is because 2020 is not in quotes. 2020 is the numeric value. So you can see that this JSON, you can have numeric values. Another demo I do with this, I show ages and calculate average of ages. So you can do numerical calculations as well. And then order by, and then, for example, I wanted an order by time, I could go ahead and do that. Let me give it one more chance, because I really want to show these queries and how they run, and how fun it is. So let's see, copy this. And I'm copying from a GitHub gist, so I got rid of the smart quotes. I yelled enough at it. Okay. So I select that, and paste that, and execute. What? We got results. Oh, hold up. Style. I want to see names. I am so not good. And at this point, I don't care about the color, but we'll label anyhow. And tell it okay. So ta-da! You can see that they are ordered by time. I'm actually not wanting to show the graph this time. I want to show you the JSON results because it's a little bit easier to see them. So you can see this one is March 1st. And if we scroll down, the next one I think is like April. There's April 1st and so on. So they're all in order. Now what I could also do then, let's show you how lucky are we going to be. Can I show name and time? Maybe. Execute. There's names and times. So you can see my objects. I'm only coming back with the properties I care about. And this is using what's called value map. So value map is going to show you both the property value and the value of that property. Now, there are others too. There's like properties and some other things I haven't shown, but I want to try to stay within an hour. I don't want to get too carried away. I do want to talk about navigating, but I'm going to do this with the slide because walking through it gets a little trickier. All right, so we have the mapping, properties, and values. This is the query I just ran. So you can see this is the sample JSON output. So we're not constrained to the little screen. I made sure we had bigger screen output to see too. Notice in my query, my value map, I have multiple property names in here. Those are the properties that came back. So. Now, let's get into the traversal. I have a few more slides left. So, if you like this talk, you might also like some other talks. which talks? I'll tell you which ones you need to go check out on YouTube. So you are here. You are at navigating data. You are here. Let me bring up my laser pointer pen. Makes it a little easier to see where here is. Okay, so you are here at navigating data. But you want to see some other talks? Well, if you like Azure, which we're assuming you like Azure, what other talks are assigned to Azure? Well, if we were to expand this, you would see a whole lot of other talks. This one in particular, I happen to be focusing on the Azure serverless functions one. But wait, there's more. So how did I even get there? Well, I need to get out of here. I need to see what else is assigned to Azure. Well, Azure to me is, I know Azure's coming in because I, the human, know that Azure has stuff coming into it. Or it's coming in from Azure. So what I'm going to do is I'm going to start with me, which is at g.v. That puts me here. In E, because this is coming into me, so is this one, and so is this one. Now, out V, the next step, I am now at Azure, I am at Dutkiewicz, and I am at Azure Cosmos DB. Out E, so do these have any outs? Yes, they do. We're going to ignore Sadukie and Cosmos DB at this point because the traversal at that point is irrelevant from what we need. But the out E, so you know that you see this one, and you know from our presentation that there are others that are associated with Azure. So all of those out edges, that's the edges of relationships, are part of where we are here with this out E. Well, we want to know the other talks that you might be interested in that are in Azure, so we need this here. We need the in V, the in vertex for that. I warned you earlier, ins and outs, we're going to be flipping around. How do we keep them straight? That's why I brought out the laser pointer pen to walk through it so you can see step by step. So, you're interested in Azure, you might also like these other talks. So, serverless function, for example, Matt's automating his dog with Azure Cognitive Services. We've got the Azure app configuration that Sam did. Sam's over in the back there. And I don't want to know why my talk is listed in there twice.
It's really good. There are 3 times.
I need to.
So would it be because the Sadukie and Azure Cosmos DB both
Yeah.
point to it?
Yeah.
Yeah.
And so, what I should have done one step further is .dedo.
You do? Yeah.
All right, so that's the path that we take. Now you can walk the path. I'm going to turn my laser pointer back off. So there is this thing called path. So if you're writing software applications that are running these queries and you want to know what steps you took to get from point A to point B, .path will help you get there. It'll tell you the steps that you took to get there. It's the breadcrumbs from the Onion Gretel story. It tells you how did you get there, what are the steps you took. That's all fine and dandy if you were to look at the output, but one step further, how do these steps perform? Performance of queries. You were waiting on that, weren't you? I say that for the end because that's when we get into the execution profile. The execution profile comes out as JSON. So you feed it the query, and at the very end, it's a terminal thing is execution profile. You can't call anything after execution profile. That's why I say it's a terminal operation. Now the execution profile, I'm not going to show the full JSON because that gets to be a little crazy. Or not, there's a lot going on in the JSON that it doesn't fit on a slide. But I will show you the things that it does show. So for this particular query, it's going to tell you the operations that it calls. It also shows things such as time. You know, I will run this query so you can see it, but it tells you it gets vertices and then it gets edges. Then it gets the neighbor vertices. So I'm on an edge, now I need all of its vertices. Then from there, give me its edges, and give me its vertices. Values name, that's its values operator. Project operator, that's just execution profile. So it tells you step by step. Let me show you what this looks like in terms of the metrics that come back. So that is this. long query here, and a mouse, and paste, and execute. Failure in submitting the query. I suspect that there's maybe what to complain about. I warned you that it has a complaint. The column reference name cannot be located in the raw records. Oh, why not? Value map, values name. I'm going to take values name out of there. Oh, it's a value map. Take the value map out of there. I didn't need the value map in there in the first place. Execute. There we go. All right, so with this JSON, you know what? Can I copy and paste this into like a, oh God. Mouse. There we go. So that's what the JSON looks like. Zooming up. Can you see that in the back? Cool. All right, so this is what happens with the execution profile. So you can see the activity ID is just your call. You're going to see the resource usage, both in the percentage usage, the amount of time it takes. You're going to see the results count for that particular operation. You're going to see the name of the operation. You're going to see some things like storage count, storage size, how long does it take, the time. The fan out is how far out it has to go with the query. So when you're working with your queries and how efficient are they, this is where those metrics will come into play. And there's a document that I have linked in the slides that will explain these metrics a little bit better. So execution profile will be what you would use for that.
So your percent time is always going to add up to 100%. It's talking about how much of that query that particular piece took.
Yeah.
Okay.
Yeah, so that's the percentage for that query execution overall. All right. So let's wrap this up. Now you want to go home and play with this? This is what you're going to want to do. There are some resources you're going to want to check out. I will make the slides. I will make the gist. The gist will include the queries I ran tonight. In addition to, I will add the ones for loading the data so that you too can see all the things that CONDG does and why you would want to check out these things. But these resources, so the Cosmos DB cheat sheets and the API except Postgres because it just got announced. They have cheat sheets for MongoDB, for Gremlin. I think there's Cassandra and the NoSQL API. So if you're like, I don't remember the syntax for this, those cheat sheets are amazing. They have them in regular size and I think the other size is legal size. Azure Cosmos DB Gremlin support and compatibility with Tinkerpop features. This is what I was saying where they don't support all of Gremlin. They have some things that they don't support. So that page I refer to often when I'm like, why doesn't this work? Practical Gremlin, the tutorial by Kelvin Lawrence. It's a book on Gremlin. It gets into things like between and filtering and all sorts of in-depth stuff. Really great thing to have on hand. The Gremlin cheat sheet by Daniel Kuppitz, again, is another cheat sheet to have on hand if you need it. And thank you all for coming this evening. If you have any other questions, feel free to reach out to me. I have a dev blog and a data blog. Long story short, I was going to focus on data all year, and then I had a Java project end up in my lap, and so the dev blog came back. So I've got a dev blog, data blog. I'm on Twitter. I'm very active on Twitter, as many of you will say. Look at Matt's like, yep. I'm also on LinkedIn. I am Sadukie everywhere. For those who don't know the story, Sadukie was a couple nickname. When I got married, I took my husband's last name, saw from Sarah Dutkiewicz, the Dutkiewicz nickname. So I am Sadukie. And I want to say thank you all for coming and learning more about Azure Cosmos DB for Apache Gremlin.
Do we have any questions for Sarah?
So, as far as like visualizing this data in an application, do you see it more like, you know, here's a list of things you might like, Or do people actually visualize the graph, just not in that Azure Data Explorer?
They won't use the Azure Data Explorer. There are libraries out there. One of the slides I have, Azure Cosmos DB has a page of it's like Linkurious and Tom Sawyer and a few other products as well that they recommend for using for graph visualizations. So yeah, that was really neat to see. Yeah.
Can two vertices have an edge that passes back and forth between them?
Yep.
Okay.
Yep. So earlier this morning, I was explaining to my sons, I have two sons, they're 8 and 10, and I was explaining to them what I was going to talk about today. Only the relationships I used were my son, who he wanted to see how he was connected to Mark Rober and Mr. Beast. Mark Rober is a NASA engineer. If you're not familiar with him, look up Mark Rober YouTube. His videos are hysterical. We have a quick connection to Mark Rober because, well, he is the son of my husband, or he could go through me, and I'm married to my husband. My husband's married to me, so my husband and I have the matching arrows on that. And then my husband did a keynote at an IT conference with Mark Rober, and so it's a direct line to. It was so surreal because later that night they did a meet and greet, and Kevin, my husband, got Facebook FaceTime chat with us, and so we got to see Kevin and Mark Rober, and he was talking with my boys and I, and he answered one of my boys' questions in the live Q&A. But then the boys were like, wait, Mama, does that mean we're connected to Mr. Beast too? I'm like, yeah, because Mark Rober appeared in the video with Mr. Beast. If you haven't seen Mr. Beast, he is a hilarious YouTuber. The things he gets away with, the things he does is entertaining to say the least. So yeah, I was explaining this to my kid, but that two-way relationship where I'm married to my husband's married to me, that means now we have two edges between us because their direction matters, that's why those relationships have to be there.
The funny thing to me about that is that if you talk to your sons about Kevin Bacon and degrees of connection, they'd say who?
Exactly.
They'd say degrees of connection to Mark Rober. Oh, cool.
Mark
yeah,
Rober,
I got it.
Yeah. So.
All right, are we ready for the raffle?
Ooh.
Okay.